In this video, we dive deep into one of the most mysterious and mind-bending phenomena in the universe: black holes. From their formation to their immense gravitational pull, discover how black holes warp space and time, what happens beyond the event horizon, and how scientists detect and study them. A black hole is a region in space where gravity is so strong that nothing, not even light, can escape from it. It forms when a massive amount of matter is squeezed into a very small area, typically as a result of a star collapsing at the end of its life. Key features of a black hole include the event horizon, the point of no return. Once something crosses this boundary, it can't escape the black hole's gravity. Another key feature is the singularity, the core of a black hole where all its mass is concentrated. It's a point of infinite density and gravity, and physics as we know it breaks down here. Because of the intense gravity, even light can't get out. There are different types of black holes in space. Stellar black holes are formed from collapsing stars and are a few times more massive than our Sun. Supermassive black holes are found in the center of galaxies and are millions to billions of times more massive than the Sun. Intermediate black holes are in between stellar and supermassive sizes. Not much is known about them. Primordial black holes are hypothetical black holes formed soon after the Big Bang. Black holes can only be detected by their effects on nearby stars and light. For example, when matter falls into a black hole, it heats up and emits X-rays, which we can observe. Have you ever wondered how black holes come into existence? Black holes are formed when a huge amount of matter is packed into a very small space, creating a gravitational field so strong that nothing can escape, not even light. Here's a simple breakdown of how they form. First, we will talk about stellar black holes. These are the most common type and form from the death of massive stars. When a star with a mass at least 8 to 10 times greater than our Sun exhausts its nuclear fuel, it can no longer support itself against gravity. The core collapses under its own weight, while the outer layers may explode outward in a supernova. If the remaining core is above a critical mass, it collapses into a black hole. Now let's talk about supermassive black holes. These black holes exist at the center of galaxies and can contain millions to billions of solar masses. Their exact formation is still uncertain, but possible scenarios include direct collapse of enormous gas clouds in the early universe, mergers of many smaller black holes and neutron stars over time, accretion of mass over billions of years, feeding off stars, gas, and dust. Now, let's talk about primordial black holes. Some hypothetical theories suggest that small black holes could have formed shortly after the Big Bang, from extremely dense regions of early matter. These remain speculative but are of interest in cosmology and dark matter research. Now we will talk about the event horizon and singularity. Event horizon. The point of no return. The event horizon is the boundary surrounding a black hole. It marks the limit beyond which nothing can escape. Not matter, not radiation, not even light. This is why black holes appear black. The event horizon is not a physical surface. You wouldn't feel anything special crossing it, but it's a mathematically defined boundary in spacetime. Its size depends on the mass of the black hole. For example, a black hole with the mass of the Sun would have an event horizon about 3 kilometers in radius. Now let's talk about singularity, where physics breaks down. At the very center of a black hole lies the singularity, a point where the curvature of spacetime becomes infinite. According to general relativity, the singularity is where all the mass of the black hole is concentrated in zero volume, resulting in infinite density and gravity. The singularity is hidden from view by the event horizon, meaning its effects are observable only through their influence on the surrounding space. Now let's know about Hawking radiation and black hole evaporation. In 1974, physicist Stephen Hawking proposed a groundbreaking idea. Black holes are not completely black. In fact, they can emit radiation, now known as Hawking radiation, and slowly lose mass over time. This idea fundamentally changed our understanding of black holes and quantum physics. Let's know about Hawking radiation. Hawking radiation is a theoretical prediction based on the principles of quantum mechanics and general relativity. In the vacuum of space, quantum fluctuations constantly create pairs of virtual particles and antiparticles. These pairs usually annihilate each other almost instantly, but near the event horizon of a black hole, something different can happen. One particle falls into the black hole, while the other escapes into space. To an outside observer, it looks like the black hole is emitting particles. Now let's know about black hole evaporation. Because Hawking radiation carries away energy, and energy is equivalent to mass via Einstein's E/mc², this means the black hole is losing mass over time. Over incredibly long time scales, this leads to black hole evaporation. The smaller the black hole becomes, the hotter it gets, and the faster it evaporates. In the final moments, the black hole could release a powerful burst of radiation before disappearing entirely. A stellar mass black hole would take far longer than the current age of the universe to evaporate. Only tiny black holes, like hypothetical primordial black holes, might evaporate within a cosmological timescale. There are some recent discoveries and images from the Event Horizon Telescope. The Event Horizon Telescope, or EHT, is a global network of radio telescopes designed to function as one Earth-sized virtual telescope, using a technique called Very Long Baseline Interferometry, or VLBI. Its mission to capture direct images of black holes and their surroundings. Expected in the coming years. Whether you're a space enthusiast or just curious about the cosmos, this video will give you a clear and fascinating overview of black holes. Subscribe for more space and science content. Thanks for watching.